Hi everybody, welcome back to the Feynman technique. So today we're going to take a look at this integral. I'm calling it the arctangent rational integral because it has an arctangent over a rational function. All right, so what we're going to do first is differentiate with respect to a on both sides, and we'll use the Leibniz rule for differentiation under the integral sign on the right-hand side to put that derivative directly inside as a partial. So we just move the derivative inside the integral sign as a partial derivative. All right, and now let's take the partial derivative of that. Well, the derivative of that is just going to be 1 over 1 plus the argument squared times the derivative with respect to a of the argument. There we go. Now we put that back into our integral, and you'll notice that these two x's are going to cancel out. So we have the derivative I prime of our original function of a is equal to this. And we can use partial fraction decomposition on that. All right. But first, before we do that, let's call u equal to x squared. That'll make doing our partial fractions a little bit easier. So we're just going to call u equal to x squared. So now our rational function inside the integrand just becomes this. And we can use partial fractions to split it up like this. And now we solve for a and b. So here's the steps. First step, second step, pause if you'd like. Third step, continuing. And finally, after all the algebra, factoring, and simplification, we end up with this, a constant multiple outside of two integrals. All right. So this is our I prime of a as it stands right now. Now, obviously, this integral right here is a standard one. That's just going to be pi over 2. All right. Now, on our second one, let's make a substitution. We're going to let v equal ax. All right. Then dv is a dx, and dx is dv over a. So our second integral simplifies like this. And again, that is this integral evaluates to pi over 2. So finally, we have I prime of a is equal to this. All right, how can we simplify this? Well, here's the steps. We factor out the pi over 2, and we just have 1 minus a upstairs and 1 minus a squared downstairs. And this, of course, is going to factor to 1 plus a, 1 minus a. That allows us to cancel the top. So finally, we have I prime of a is equal to this. And now we just have to integrate back to get I of a. All right, we can see that we have a pi over 2 as a constant. That comes out. And we have I of a is equal to pi over 2 natural log of 1 plus a, plus this annoying constant of integration that we have to solve for. We can solve for that by figuring out that I of 0 is equal to 0 and plugging that in to solve for c. So I of 0 is equal to 0, which is also equal to what you get when you plug in 0 for I of a. And that's right here. And you can see this is just going to be natural log 1, making the entire right-hand side just c and the entire left-hand side just 0. So c is equal to 0. And we have our final representation for I of a. All right, guys, I hope you enjoyed that, and we'll see you next time.